All right, welcome back once again. Today we're going to talk about domain and range. Talked a little bit about it yesterday, but we're going to go through some finding domain and range. If you're given a graph, it's kind of the easy part. And then also finding domain just if you're given just a function and don't have a graph at all. Okay, this should be reviewed for you. So there's three different ways we can write domain and range. We can either use interval notation, which is parentheses and brackets. There's inequality notation, which uses the less than or greater than signs, or less than or equal to, greater than or equal to. And then there's step builder notation. The nice thing about step builder notation is it's basically the same thing as inequality notation. It just uses these extra symbols. So it's got that little squiggly bracket, and then X is an element of, that's what that symbol means, the element of, and then real numbers, vertical line means such that, and then your inequality goes after that, okay? Usually when I write things myself, I usually use interval notation. Sometimes I use inequality. It's pretty rare that I myself write set notation, but you do have to know how to recognize all those things, okay? So when you write it yourself, I don't care what you write, but definitely know how to, definitely be able to recognize what each one of them say, okay? Also, just a quick review from your algebra days. Remember, domain is always written from left to right, and the range is always written from low to high. And also, of course, we want to be mindful of the quote-unquote starting or ending points, if there is one. If it's at the open circle, it's going to be non-inclusive, so you can use a parentheses or just a plain less than or greater than. If it's filled in circle, if it's a hard end point, then that's where your bracket or less than or equal to sign comes in. Okay, let's go to a couple graphs real quick. I'm going to go through these pretty quickly. The main thing I want to do is the algebraic part, but let's go through these real quick. So domain, again, from left to right. So 1, 2, 3, 4, 5, 7. It goes from -6 to +6. So, and again, notice the filled in circles. So your domain in interval notation would just be -6 to 6. If you want to write it as an inequality, X can be anything in between these two things. So it would be -6 less than or equal to X less than or equal to 6. And then step builder, this is the only time I'll write all three of them at once. You don't have to write all three. X is an element of real numbers such that, and then the inequality. Oops, about that. So I think, and that just in that one example, I think you see why I tend to gravitate towards the interval notation, because it just tends to be shorter a lot of times. Range, you do the exact same thing, but now we go from low to high, the y value. So notice my lowest value is 0. My highest value is 1, 2, 3, 4, 5, 6. 6 again. So my range is going to be from 0 to 6. And again, it's inclusive, includes those endpoints. You're filled in, so it'll be the bracket again. Okay? And again, you can do the same thing with the inequality and step builder. I'm not going to do that just for the sake of time. Let's move over to the one on the right here. So again, domain left to right. 1, 2, 3, 4, 5, 6, 7. That's -7. And 1, 2, 3, 4. That's 5. So my domain this time, notice on the -7, it's a filled in endpoint, but my 5, it's an open circle, so that's not getting all the way there. What that means, it's getting super close, but not all the way to 5. It doesn't include that point. So that's going to get a parentheses. If you're doing this in inequality, and I will do this one more here, remember, if it's a hard endpoint, if it includes that, that gets the equal sign underneath the inequality. But if it's not included, like the 5 is, that just gets a plain inequality without the line under it. Okay? And then the range is the same way. Again, low to high, 1, 2, looks like -3 is that line, up to 1. So same deal. Now it gets to -3, but doesn't quite get to 1, so that's going to get a parentheses. Okay? Let's look at two more graphs and we'll get into some algebraic stuff. So on the left we have basically a circle. 1, 2, 3, 1, 2, 3, 4. Looks like it goes 4 on each way. So again, and it looks like it hits the line there. So the domain is going from left to right, -4 to 4. Range, same thing, -4 to 4. Easy enough. And then the last one, if you want to look at the last one, pause the video real quick and see if you can get the last one before I go through the answer. So the domain here, left to right, looks like that. 1, 2, -3, 1, 2, 3, 4. And again, both of those are open circles, so these are going to be parentheses on both sides. And then the range starts at 0, 1, 2, 3, 4, 5. Looks like both sides go to 5. But again, on the bottom of that, 0 is included, so that gets a bracket. And then the top side doesn't include that on either end. So that's going to be like that. Okay? So that's graphical domain and range. I don't have any homework problems on that. I think it's pretty straightforward. But again, domain left to right, range low to high. Let's look at some rules for algebraic domain. Okay? I'm gonna run through. I'm gonna skip these two guys real quick just for the sake of time. But let's look at algebraic domain. So we generally don't worry too much about the range. If you don't have a graph, range can be a little bit tricky to kind of figure out. And really, we don't care a whole lot about it. The main thing we care about, if you're just given a function, is knowing what the domain is, knowing where your restrictions for the x values are. Okay? So the first one, there's only really 3 you have to know. So the first one is, does the function have an x in the denominator? In other words, that's for our rational functions, remember your parent functions. And so here's the rule. Remember, if you have a fraction and x in the denominator, from elementary school, what's the only number that you're not allowed to divide by? Well, 0. Not allowed to divide by 0. So that's what you do, right? So you set the denominator, whatever it is, you set that equal to 0 and solve it. And the domain is everything else. It just cannot be that one or however many solutions you end up getting. So you almost don't even care about the top. When we start graphing rational functions later in the year, we'll kind of care what's going on top. But for the domain, we only look at the bottom. So we set the bottom, whatever the denominator is, equal to 0, and just solve it. So we got 2x equals 3, so x equals 3 over 2. And then when you write your domain, it's everything except that one number, right? So it goes from negative infinity to positive infinity. It just skips over 3 over 2. So the way we write that is negative infinity to 3 over 2 with a parentheses, and then union 3 over 2 to infinity. Okay, you could also write that as just all real numbers, so that fancy R for real numbers, comma, x not equal to 3 over 2. That's just as valid. I would take either one of those, because technically that x not equal to 3 over 2 is an inequality. Okay? Sometimes you may get 2 solutions, because look at the one on the right. Again, the top doesn't matter. It matters in terms of what the graph looks like, but as far as the domain, all we care about is the bottom. And remember, folks, if you have a quadratic and you set it equal to 0, factor, 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 factor. It's not going away. So we know how to factor this. What multiplies to 8 and adds to 6? And again, set each of those equal to 0, so you got x equals -4 and x equals -2. And again, when you write the domain, it's all real numbers, negative infinity to infinity, except these guys. When you're writing interval notation, it's a little bit longer. Let me try that again. Negative infinity to -4, union, -4 to -2, includes all those numbers, and then it kind of jumps over -2 and goes on to infinity. Okay? And again, if you want to kind of do the shortcut way, you could do all real numbers, x not equal to -4, -2. That's fine. Okay, so that's one. So if you get a fraction, x in the denominator, whatever's in the bottom, set it equal to 0, solve it, and it's everything else. Okay. The second kind of situation where you have to worry about the domain is if you have a radical or a square root function. And notice I did say even root. So we can have like a square root or a fourth root, or a sixth root, anything like that is going to be the same situation. And if you remember Algebra 2 days, we cannot take the square root of a negative number. So that tells us what we got to do. So that says, so what we do, whatever's on the inside of that thing, remember, it can be a square root, it can be a fourth root, whatever. If that little index, that little tiny number is even, we're doing the same thing. And we set the inside, called the radicand, we set the inside greater than or equal to 0 and solve it. Once you solve it, you're done. That is your domain. Okay? Now, the one thing to remember here is this last bullet point. If you have an odd index, so if you have like a cube root of something or fifth root, if that little number is odd, then there's nothing to do. It's automatically all real numbers. Okay? So let's do a couple of these guys real quick. So again, you don't care about anything on the outside. All you care about is the inside. So we got 4x minus 2 greater than or equal to 0. And just solve it, just like you do anything else. So 4x greater than or equal to 2. And then x is greater than or equal to 2 over 4, which simplifies to 1/2. And honestly, that's an inequality, so heck, you're done. You can leave it like that if you want to. If you love interval notation, you always want to use that, it would be bracket 1/2 to infinity, because it's going greater than, so it's going to the right as those numbers get bigger. Middle equation, again, even index, so we do the same exact thing. 5 minus 2x greater than or equal to 0. I think most everybody would do just subtract 5 from both sides. And then divide by -2, but you got to remember your algebra 1. So if we divide by a negative and we have an inequality, the inequality flips. So it'd be x is less than or equal to 5 over 2. So again, you can write it like this, and that is a 100% valid answer. If you want to do interval notation, remember less than is going to the left, so we're going to negative infinity to 5 over 2, again with a bracket. And then my last example, this will take about 10 seconds, because notice my little number is odd. There's no math to do, that is all real numbers. Or if you want to write negative infinity to infinity, either way. Okay, so that's 2. So fractions at the bottom equal to 0, that was the first set of examples. If you have an even radical, an even root, so the inside greater than or equal to 0, solve it. The last one, similar to a radical function, is if you have a log function. Remember, this is ln or log, kind of mean the same thing. And if you remember that graph, it had an asymptote there on the axis, on the y-axis. So that means we said the inside again, just like the radical. We said the inside, it's called the argument. We said the inside greater than 0. Notice, just greater than, not greater than or equal to. And again, solve it, and you're done. Okay, outside doesn't matter. So let's take a look at the first example. So we have 2x minus 10 greater than 0. Again, get x by itself. And then divide by 2. And that's it, you're done. Notice that it's just greater than. So if you're doing interval notation, going 5 to the right, getting greater, so 5 to infinity. And then for the last one, again, that's ln. When I write it by hand, I always do a cursive L, so everybody knows it's not a 1. Same thing. But again, inside, whatever it is, greater than 0. I think in this case, since it's just a single x, I think a lot of people might just move the x over, which is fine. So you can write it like that. That's what I call kind of clunky though. So we like having the x first and kind of reading it left to right. So if you do kind of a mirror image, that becomes x is less than 6. Okay, and again, that's just like that. By the way, if you leave it as 6 greater than x, I'm going to count it right. It's because it certainly is. But remember what that means. That's 6 is less than 6, so that's going from negative infinity to 6, and then stop in there. Okay, folks, that's it. If you see anything else, if you do not see a fraction or an even radical or a log, the domain is automatically all real numbers. Okay, so it is automatically everything else is all real numbers. Okay? So everything, if you don't see fraction, even root, or log, then it is all real numbers. And remember, if you want to write that as negative infinity or infinity, that's okay too. Okay? So that is how you find domain. You're gonna have an assignment on doing that algebraically. That will definitely be on the test. So know those three things: rational, radical, and log. Everything else will be on numbers, and you'll be good to go. Until next time, stay safe.